Go to this one which says find the speed of the ball in example at t equal to 1 at exact and at t equal to 2. Well, this is now instantaneous. Once you see them say at t equal to 1, so we need to find at t equal to 1. So it's now instantaneous speed because they say speed. So we're going to say delta y over delta t is just going to be f of, we can say t1 plus h, or we can just call it t0 plus h. Don't be confused by that. Okay, we only should have one t. Okay, which instead of writing t2, we write t0 or t1 plus h. Okay, then we say minus f of t1 or f of t0, which we have used this time, and it is all divided by h. It's the same thing. So now this is going to be very easy because all we are doing is we should remember what our f of t is. So it's like the first statement we put, always just skipping. The first statement you put is what f of t is. Okay, you need to have it, the f of t. So in here we don't have it. We need to know that this is for something falling in the air. So it is 4.9 t squared. Okay, this is what you have. Remember, you first start by saying y is equal to 4.9 t squared. Then you say let y be equal to f of t, which means f of t is equal to 4.9 t squared. Okay, and that is what it is. And now we can put it. So we have here f of t0 plus h, and we have f of t. So now what about, let's put the things, maybe everything, before we put it in the last formula. So now we have f of t, which means we can come and get f of, remember we are getting for instantaneous. So remember we should be able to find f of t0 is equal to 4.9 by t0 all squared, which is going to be 4.9 by t0. What is the first one? It is at 1 second, so by 1 squared, which is just going to be 4.9. And you can say f of t0 plus h is equal to 4.9. Where there is t, we are putting t0 plus h. So it was there. So it will be t0 plus h all squared. Okay? Only where there was t, that's where we are putting it. And here, what are we going to have? It's 4.9 by t0 is 1. So it's 1 plus h all squared. And this is what we'll be having as our thing, as our f of t0 plus h. It's 4.9 multiplying 1 plus h all squared. So now we can go ahead and you can put it to say, you can even simplify this because we're still going to do that. Okay, to make it be 4.9 times 1, it is like a 4.9. Then 4, okay, we can first expand, right? We can say 4.9 is therefore multiplying. This all squared is like you square the 1, it's 1. You multiply these two together, so it's 1 times h is h. You double that. You say times 2, you get 2h. So you multiply them together, then you double, then you square the last thing. That's how you expand it. So it'll be h squared. You square the first thing, you multiply them together, you get an answer, you double it, then you square the last thing. So here is what it is. Then we expand. 4.9 times 1 is 4.9. 4.9 times 2h is plus 9.8h. 4.9 plus h squared is plus 4.9h squared. So here we can now come and say that delta y for instantaneous over delta t is equal to f of t0 plus h minus f of t0. So remember to substitute the t0. Here it was 1, so wherever there was t0, we are removing and put 1. Remember to substitute t0. But h you don't substitute. So here, and it is all over h. Remember that it is all over h. What is f of t0 plus h? We found 4.9 plus 9.8h minus 4.9h squared. And it is minus f of t0 is just 4.9. So you can say it is minus 4.9. And it's all over h. What is h? It's just h. H doesn't change. So here what do we end up having? 4.9 here minus this 4.9. They will take each other to 0. And we'll remain with 9.8h minus 4.9h squared. Okay? And it's all divided by h. Now what do? We have to simplify. Remember, we have to simplify. So we bring h out and we remain with 9.8 minus 4.9h. Okay? Because there were two of them. One remains now. And it is all divided by h. The h and h will cancel. We'll end up having 9.8 minus 4.9h. Okay? And here we say now, when we want to find the instantaneous value, remember we say now h should become a 0. So you can say for instantaneous, you say now let h be 0. So this, you can say it'll be therefore equal to 9.8 minus 4.9 by 0. 4.9 by 0 is 0, and you just get 9.8. And this is meters per second, and this is your instantaneous value, and you are done. Okay, if you can do the same working in less space, that is even better, because we are now doing that part T2, which we know that now T0 is 2 seconds. And remember, we have our f of t being equal to 4.9 t squared. So we can find f of T0. Okay, and this is just going to be 4.9 by T0 all squared, which T0, you know, it's 2, so it'll be 4.9 by 2 squared, which is like 4.9 by 4. Okay, and we've gotten it many, and our solution here was 19.6, right? Now we should then find f of T0 plus h, which becomes 4.9 multiplying, where there is t, we are now putting T0 plus h, and it's squared where there was t. Okay, remember, only where there was t. So this becomes 4.9 multiplying, what is my T0 now? It is 2, so it is 2 plus h all squared. Okay, if you want, we can go and put it in the equation looking like this, because some want to see it like that, I know. So we can come and say that delta y over delta t is f of T0 plus h minus f of T0 all over h. This becomes equal to 4.9 multiplying 2 plus h all squared minus f of T0, which is 19.6, and it's all over h. A lot of people want to see this, I know. So this becomes now 4.9 multiplying 2 plus h all squared. You square the first one, 4. You multiply them together. 2 times h is 2h. You double that answer, becomes 4h. Then you square the last thing, h squared. Then it's all minus 19.6, and it's divided by h. What is 4.9 by 4? You get 19.6. 4.9 by 4h, you say plus 19.6h. 4.9 times h squared is plus 4.9h squared minus 19.6, all divided by h. Now 19.6 and 19.6 will cancel. We'll end up remaining with 19.6h plus 4.9h squared, which you can start by 4.9h squared. So 4.9h squared plus 19.6h, all divided by h. Now what do? We factor out an h at the top. It becomes h. Here we remain with 4.9h plus here the h is gone. We remain with only as 19.6. And it's all being divided by h, which h and h will cancel. Here you get 4.9h plus 19.6. Then you can say here, you can now say here, let's h equal to 0, because we want go towards 0, or we can say b equal to 0. We want it when it's instantaneous, which h is the difference between the two values. And here, for it to be instantaneous, the two values should be exactly at one position. So that means h should be 0, because h is the difference between the two values. So it becomes 4.9 by 0 plus 19.6. This becomes a 0, and we'll remain with 19.6, and it is meters per second. This becomes our instantaneous value of speed, and we are done with this one. We'll go to the next one. Goodbye for now.